Thanks everyone for joining in for today's webinar on critical minerals. What, how, why all the hype? You may have just seen the message pop up or hear the words that we are recording the webinar today, and the recording will be available later on our website. And after the webinar today, we will be sending out an email that will have the link for you to be able to get on the internet and have access to the slides that are presented today. First, I'd like to thank all the sponsors that are sponsoring the program through which this webinar is being presented. I'll talk a little more about the program, but I will save that till the end. But thank you to all the sponsors you see listed here for today's program. Next slide, please, Dan. So the presenters today, of course, is me. I'm John Kay, the one talking. I'm the principal engineer at the EERC, and I'm also overseeing the project supporting this webinar today. The main speaker for the webinar will be Bruce Folkedahl, who is a senior research engineer at the EERC. And we have a guest speaker, Ryan Ellison, who is going to give us a little bit of perspective on the commercial side about the importance of critical minerals. Next slide, please. So the big question here, of course, is why is this important and why should we care? And the bottom line is critical minerals play a very important part in practically everything you use in your everyday life. One of the more important aspects of that is the fact that there isn't large domestic availability of these materials. Next slide, Dan. We are heavily reliant on the imports of many of these elements to be able to manufacture and have access to the things that we enjoy every day. So we thought we would start with this first seminar to talk about these things. But at the end of the day, next slide, we believe that the Williston Basin is in a very unique position. And we believe that we have a few factors that put us in a realm for a success for being able to utilize critical mineral resources that we have within our basin. The first one, of course, is the reputation and the research expertise of those entities that are within the basin. Second, of course, is we have just years and years and scores of experience in mining and in processing, which will really come into play. Three, we have a very unparalleled lignite coal resource within this basin that is going to give us good access to a lot of these critical minerals. One of the more important things is number 4, which is the fact that state governments are very supportive of natural resource development within the Williston Basin region. And so taking all of that together, then you get collaborations within the basin with all of this expertise and accessibility that we have is going to bring us together to be able to answer major questions that come into play as we look at these critical minerals and work towards an economy where we can develop what we have within the basin to ease our reliance on imports and to strengthen our ability on the domestic side for these. So at the end of the day here, I think what we're really talking about within the Williston Basin is the fact that it's going to have a very large regional effect and probably is going to interact with other basins that are going to have similar abilities in the development of the resources that they have. And so even though we're going to be talking ultimately about what is available within the Williston Basin, we are really talking throughout the region. And so with that, then next slide, Dan, just want to take a few minutes to talk about, of course, we have a series of webinars that we're going to be covering. And today's seminar is the one that you're all here for, but we're going to have one here in November, which is going to talk about the technologies and how to move forward, developing and dealing and processing these critical materials that are going to be available. And then, of course, in January, we'll have another presentation where we will talk a little more on the business side, what our strengths and our assets and what will be needed to further enhance and drive the business case for the utilization of critical minerals within the Williston Basin. And so the final presentation in this series, our webinar, will be in March. And this is one I will certainly encourage all of you if you're available to attend, because in this webinar, then we will start to put together the overall picture of what we believe those processes that will come into play for the Williston Basin and how we step into the future in developing those critical minerals and getting them out to market and through production. And in the course of doing that, you will also have opportunities to become a member of the team as we step forward through this and help guide this progression as we go through these next steps. So with that, I think we'll just jump right into the meat of the webinar today. And I'd like to introduce Bruce Folkedahl, Senior Research Engineer at the EERC, who has been very involved over several years now in critical minerals within the Williston Basin. So with that, Bruce, I'll turn it over to you.
Thanks, John. Appreciate the introduction. I'm going to talk a little bit about the technicalities involved with critical minerals and materials and kind of define them, more specific applications we use them in, and why they're important, where are they resourced out of, and what we might be able to do going forward. Next slide, please. So defining critical minerals, this is an umbrella kind of term for all of the minerals and materials I'm talking about. Critical minerals are essential to modern economy and the national security of the United States, but they're determined to be critical because they have a supply chain that is subject to disruption. And that means that we don't either produce any, or we produce only a small amount and refine them in the United States. And the majority of it occurs overseas in some other country that may or may not be aggressive with the United States at some point in the future. Rare earth elements are a subset of those critical minerals. Rare earth elements, kind of a misnomer. They're not really rare. They're just very evenly distributed throughout the crust of the earth, and they're always found together. And I'll show you what they all are in a slide coming up. But they're always found together, and they're very chemically similar, elementally similar. So it's very hard to separate them out into the individual minerals and materials that we want. But each one has a different use. It's not like they can all be used in one application, but they're specific to certain applications. And then critical minerals, again, the generic term that is an umbrella over all of the other minerals that we're going to talk about. And this list of critical minerals that I'm going to show you, this is determined by the USGS, United States Geologic Survey, along with input from Department of Energy and other groups. And it's updated every couple of years. Next slide, please. This is a periodic table, and it shows you all of the critical minerals. There's two groups here, and that is the blue, which is the rare earth elements down at the bottom, plus scandium and yttrium. This is the lanthanide series. And when they were first found, they were all thought to be yttrium. And it took decades of work to be able to discover that, no, there's bunches of other separate elements in there that can be teased out. But because they're so chemically and electronically similar, it's very hard to separate them out into their individual elements. And then all of the gray here are the other critical minerals, again, as determined by the USGS and other government entities. And typically that revolves around the fact that we don't produce enough of these in the United States for our own domestic needs, and a majority of them are processed or produced overseas. Also, one other distinction is that the blue materials, the rare earths, they're divided up into the light rare earth elements, which are on the left-hand side, and then at about gadolinium there, the darker blue, which are considered the heavy rare earth elements. And the heavy rare earth elements are typically the more desirable, and they have more economic value. And we'll give some reasons for that going through. Next slide, please. A couple of different critical minerals, we would just take it, not really at random, but gallium and germanium. We find them in the Williston Basin, and they're critical for the electronics industry, and we have no domestic source for them. And they're used in chips, solar cells, LEDs, lasers, fiber optics, all kinds of uses that are determinate in our economic well-being as well as national defense for the United States. Next slide, please. Another set of materials and product that they're used in, lithium-ion batteries, which use the lithium, cobalt, manganese, nickel, and graphite in their development and usage. And these are not produced in enough quantity in the United States. And as we know, as we transition away from fossil fuel energies and more to renewable energies, we're going to have a lot more electric vehicles, a lot more wind turbines, which will need batteries to store that energy so that when the wind is not blowing, you can put that energy out onto the grid and keep powering people's homes and businesses as best we can, so that not only the electric vehicles that are going to be needed, all of these lithium batteries, along with your cell phones and other applications, but large scale energy storage, grid scale energy storage. The only thing available for that right now is lithium ion battery materials. There are other batteries that are in development that show great promise for the future, but they're not here yet. And the demand for these batteries is doubling every couple of years. So it becomes more and more critical, again, that word, as we go forward, that we find our own domestic sources of these. Next slide, please. Another group of critical minerals, the platinum group, and this is the 6 particular metals that typically occur together. 5 of them are considered critical: platinum, palladium, iridium, ruthenium, and rhodium. Osmium is the 6th material, but it's not considered critical. It doesn't have the use that these others do, which are used in catalytic converters in cars, which to reduce the emissions of nitrogen oxides, which are bad for the environment. An important aspect they're used in is electrolysis for hydrogen. As we go forward and move away from fossil fuels for our power systems, hydrogen is going to become a huge player across the U.S. for use in fuel cells and other applications that will produce energy and power and other things. And they're also used in all kinds of medicine and electronics and other industries in small amounts, sometimes called the investment metals only because they're just so highly priced. And you can actually buy coins of these materials and use them as an investment type material. But the real big issue is that South African mines produce 60% of the global supply of these. So we don't have near enough domestic supply, and we need more of them. Next slide, please. And then the rare earth elements, which are a subset of these critical minerals that are being focused on, they're used in a host of applications, which are shown here. And again, they're not all interchangeable between them for each application. And so there's a large use for them, and we're more than 80% reliant on imports, as John pointed out earlier. And so there's a great desire and need for us to find domestic resources for these elements. Next slide, please. National security, I mentioned. This is just illustrating how much of these materials, rare earth elements only, are used in the application for these defense items, and it becomes very, very large. And if we're sourcing 80% of these rare earth elements from countries that may be antagonistic to us and want to cut us off, that could put us in a precarious situation for our security. United States. Next slide, please. So what resources do we have? Well, in specific, we're talking about the Williston Basin here, which is outlined in red behind these words. And it crosses from North Dakota into Montana, dips down into South Dakota. It also goes up into Canada, but we're focused only on domestic resources. So the United States portion of Williston Basin, that's what we'll talk about a little bit going forward here. Next slide, please. So one of the things that got started was when Department of Energy and Department of Defense and other federal agencies started looking at these elements and saying, okay, we need to get serious about domestic resources. And back in 2012, they contracted with a fellow by the name of Ackman and some of his co-authors, as shown at the bottom here. And they did a study and looked around the United States. What are the resources for them? And one of the things they discovered is that we might be producing 40,000 tons annually of rare earths with coal mining in all the operating coal mines at that time in 2012. And of that, the heavy rare earths might exceed 10,000 tons annually. Well, that was a significant find because in 2021, the US used approximately 6,000 tons. And so we may be producing many times more rare earth elements needed for our domestic application than required. And so that's very significant. And the idea that it was coming out of operating coal mines is also important. And I'll talk about that a little bit going forward. Next slide, please. So we'll talk about the states that's associated with the Williston Basin. North Dakota, what do we have to offer? Well, we've got the world's largest lignite deposit, 350 billion tons. It's huge. The number of seams is large, and some of these seams have high rare earth element concentrations. And we've gone out, the Energy Environmental Research Center, in association with North Dakota U.S. Geologic Survey, and tried to sample and characterize as many of these coal seams as we can. Now, we've gone to the mines and we've characterized them quite well for the open mines that are available. The rest of this is coming from outcrops where these coal seams bridge the surface of Earth, and so we can get at them and sample and analyze them for the concentrations of rare earths. Now, the DOE has set as a threshold for economically viable ore bodies for the extraction of rare earth elements at 300 parts per million total rare earth elements. So a very low number, but still, that's how high you have to get to be able to even be considered a potential resource for rare earths. The Harmon-Hanson coal seam in North Dakota, we found places where that is approaching 1,000 parts per million. So very high concentrations. And so it has the potential to have a significant overall quantity of rare earth elements in just that one seam. One of the things that we need to do better is characterize all these seams. We've done a fair job in North Dakota, again, thanks to North Dakota Geologic Survey and some previous work we did funded under the Department of Energy. More work needs to be done. Next slide, please. If we go over into Montana, Montana Tech has been working on mapping out their coal seams, and it's been a real good resource and a valuable source of information for the work that we're doing here. But yet there's still a lot more characterization needs to be done. We've gone across and obtained samples in the coal beds in the eastern portion of Montana, but much more work needs to be done in Montana to characterize those, so we get a better idea of what the overall resource of the Williston Basin is. Next slide, please. And then if we got down into South Dakota, there is no active coal mines currently in South Dakota, but under this project that we're talking about, John will explain a little bit more about it later, some of the high concentration samples in lignite coals that we found were in the very southwest corner of North Dakota. And we're going to be doing some sampling, not us actually, but the South Dakota Geologic Survey in partnership with us is going to be doing some sampling, as you can see, right across the border near where those coal seams were found with high concentration. We'll be starting to characterize some of the potential in South Dakota, again, to generate the knowledge needed for where is this resource, and how easy is it to get to, and where is it economically viable. Next slide, please. And going back to the periodic table with critical minerals and rare earths, in our work at UND, EERC, and along with the Geologic Survey, these are the elements wrapped in yellow that we would be targeting because they are there in a high enough concentration to be extractable and to concentrate them up, as well as the fact that they have a relatively high economic value and the greatest potential to contribute to the Williston Basin market. Not all of these are rare earths. You can see the blue showing the rare earths, and then gallium and germanium up there discussed as their application in the electronics industry. Carbon is one. We'll be sourcing that directly from the lignite, from the coal itself. And we've been working on applications to convert that coal portion of it into graphite and graphene, which are highly desirable products needed in the marketplace and are critical, again, according to the United States Geologic Survey, for U.S. economic environment and for our national security. Two more up there that I'll mention just briefly, and we'll talk about a little bit, but lithium and magnesium are also in there, but they would not be coming from coal seams or other ore bodies, but from produced water that comes flowing back out of the oil wells with the production of oil. Next slide, please. So once you find it, you've got to look at ways to process it and get them out of different resources. Talks about the coal mines, obviously we've developed ways for that. When you extract that coal and you combust it to produce electricity, you're left with coal ash. And all of the critical minerals basically end up, with the exception of carbon, end up in the coal ash, and you've concentrated them up. And so we've developed techniques to extract those materials from the ash material. Produced water, when it flows back with the production of oil, is generally piped away or trucked away and then sent downhole to many thousands of feet underground into saline aquifers to dispose of it. But there is processes. One such process is called the chloralkali process that can take that water and extract certain things from it. And the chloralkali is focused on producing hydrochloric acid and sodium hydroxide base material. So you can produce acids and bases from that, which are highly valuable and used not only in the production of oil, but also in the extraction processes for bringing out these critical materials out of the different resources. And then that makes it economically viable then to get at the small amounts of lithium and magnesium that are present in that produced water as well. So it's a value add system. So that's where they would come into play. We've looked at the shales in North Dakota. The reason we started to look at them is because We received a sample from the Basin shale that was analyzed for rare earth elements and had 2,400 ppm, parts per million, of rare earths. So if you remember back, I said that the Department of Energy has determined that the level of total rare earths in an ore body for being considered an economically viable resource for rare earths is 300 parts per million. The coals that we've looked at, some of them have been as high as 1,000, and now we're talking about 2.5 times that value. And so that made us interested in going out and looking at some of the shales. We've looked at several of the particular shales available or outcropping in North Dakota, and some of them have significant values, again, of rare earths. More needs to be done to characterize them and to find out where the highest concentrations are at, and then to look at the extraction techniques. And then also there's a lot of coal seams in North Dakota, these lignite coal seams, they're just too deep that you're never going to be able to mine them economically and extract them. And so we've looked at developing in situ extraction technologies to go into these deep mines or deep unminable coal seams and see if we can withdraw those critical minerals. Next slide, please. When Ackman said in his study that I talked about that we might be producing inadvertently in coal mining in the United States 40,000 tons of rare earths, the important thing about that is that those mines were up and operating and already working. They've absorbed the cost of permitting, the long slog that it takes to get through that process. They've got the mines opened up and are working. They've got the transportation costs absorbed in taking those coals from the mine to where they're going to be used, and then crushing and grinding, the processing costs there, high energy, expensive processing, so that these materials would be available for extracting critical minerals. So it really shows that is an important aspect because they've already absorbed those costs. And just as an aside, approximately 7 to 10 years in the United States to get a new mining operation permitted and up and running, if you can get it up and running at all. And so there's potential for value added recovery of critical minerals in the existing mines currently operating. Next slide, please. So the opportunity that we see for the Williston Basin is, in the current situation, almost all of these processes are done outside the United States. There is some mining of rare earths in a hard rock mining situation in California that is occurring, but it's a very small amount. And even at that, when they mine that ore out for its rare earths, they separate partially and concentrate up that ore to a certain level, and then it's shipped overseas for processing, separation of the rare earths, putting them into an intermediary form, which could be an oxide or a carbonate or some other form, and then metallization, producing that material into a metal, and then alloying it with other metals to get the right form of material that would be put into consumer goods and used in applications. So we get a little bit of mining operation in the US, but I think in the possible future is that 4 or 5 of these processes can be done right here in the Williston Basin. We can mine the material out. We have a lot of experience in mining coal. We can get that out. We can crush it. We can separate the rare earth and critical minerals from that ore, which would be the carbon, the coal, place them into intermediary forms, metallize them so that we have these metals, and then alloy them and ship them around the United States where they can be put into consumer goods and applications. Next slide, please. And so that's a quick version of what I think the Williston Basin has to offer. And now I'm going to turn it over to Ryan Ellison here, and he's going to give us a little bit of information on the use of these materials. Ryan's a graduate of University of North Dakota. Ryan, after college, went on to fly civil and military aircraft, and then went on to undertake aerospace system engineering in the US and European Union governments. Ryan is a founder of Clean Republic, which is Dakota Lithium, in 2009, and started working full-time on the project in 2015. And he is the chairman of the board and the director of business development and investor relations for Dakota Lithium. And with that, Ryan, you are up.
Great, Bruce. Thank you so much. Can you hear me okay? Just a little sound check here.
Yes, we can, Ryan.
Okay, great. You never know with this technology, Bruce. I really appreciate that presentation. I wasn't quite sure what I would be listening to today, but that from a business perspective was very exciting. As Bruce mentioned, I'm the chairman and founder of Dakota Lithium. Yeah, if you just, next slide, actually. We are a company that got our start in Grand Forks. The three founders of us, we all met at the University of North Dakota. Two of us are graduates from the aviation school, and then Dr. Ho Young was a visiting professor at UND, still there, and has worked closely with us on a lot of our technology developments, which I'm going to get to in a little bit. So we have very close ties with the University of North Dakota. We founded the company there. The company is now headquartered in Seattle, Washington, but we still have some operations in North Dakota, and hopefully in a few weeks we'll be able to announce some exciting stuff in Grand Forks with our operations. We'll see. So yeah, today the business is really focused today, and where we got our start was developing battery packs like you see on the screen. So a lot of the lithium and the energy storage discussion that you hear in the media or in the news is really around electric vehicle energy storage, and a lot of discussion gets missed around all the other millions of devices out on the planet that are going to need and require energy storage. So as a company, we like to refer to ourselves as a business that provides energy storage solutions for everything just below commercial vehicles and down. So that's everything from small tractors, ride-on lawnmowers, all the way down to these smaller batteries that you see on the screen can be used for backup power supplies for home security systems or for backup power supplies for computers. We run the whole gamut. And with that, when we got into that work, we originally started with manufacturing of the battery packs, or these boxes that you see here. We assembled the cells, built the packs, and off they went. If you go to the next slide, I got to remember my slide order. As a lot of you are aware, if you follow the energy space, which is the big hot thing at the moment, the US is really far behind in its ability to provide a supply chain for energy storage. I would say 90% of the commercial packs that you're seeing that are going into cars or other vehicles today are coming from Asia, primarily China or the Shenzhen province of China. And so this is from the National Blueprint for the DOE for lithium batteries. And really what it's saying is, by the US vision for our energy storage supply chain is to have a US supply chain by 2030 to meet all of our long-term goals and become competitive on the marketplace. So this is a economic piece behind this, but there's also a national security piece behind this, because energy storage is becoming so critical in all the different military elements that you're seeing out there. Next slide. This is just a little bit on the size and the scope of what the lithium energy storage space is expected to grow to over the next, well, till 2040. This is from the DOE as well. And I think that these numbers are, this slide is a few years old, so these numbers are actually probably much larger than this. But we are seeing this growth ourselves in our own company. In the last 2.5 years, we've had 400% growth in terms of sales of our packs for lithium storage or energy storage. So it's growing rapidly. And I think the problem with this, or the problem that we ran into, and I'm going to get into why this is all related to critical minerals in a moment, but the problem that we ran into the last few years was obviously the supply chain. I think we all heard on the news about how ships were taking forever to get into port. We were experiencing that as well. It was taking us 6 to 8 months to get a container of our supplies here to the United States. And with this type of growth that you see on the charts, having supply chain challenges and backlogs like that is a major risk to everything that we're trying to do here in the United States. So the next slide. So as a company, when we started at the university and Dr. Ho Young started work there, one of the first things that we started working with was the lithium. So if I stop for a second, the type of lithium, there's many types of lithium batteries out there. The type of lithium battery that we make is a called lithium iron phosphate. It's not as prevalent in vehicles, though it's becoming more prevalent, primarily because it's safer and it has a much longer life cycle than nickel, magnesium, cobalt, or other variations of. And so Dr. Ho Young started doing a lot of work with the University of North Dakota and trying to develop different manufacturing processes and different chemicals that could be used, or minerals that could be used in the North Dakota environment within the lithium iron phosphate cathode material. So the way a battery is constructed is that first you need to mine these raw materials, and then they need to be made into either an anode or a cathode material. And that's the materials processing that you see here. So when we talk in our business, when we're talking about critical minerals, I mean, obviously the lithium is a very critical mineral for us. Iron and phosphate are not as critical. They're pretty abundant, which is one nice thing about the chemistry that we use. But then taking those materials and those minerals and making them into a material that we can use within the cells and in the battery packs are extremely important. It's the most critical part of the process. So that's one thing we're focusing on as a company right now, is bringing back our cathode manufacturing to the United States. And the only way that we can do that is if we have a raw material supply here in North America, that whether that be Canada or the United States. So we as a company are really focused on that. And it's enough material that having it close to our production facility is very important. So we're not talking about building a, if we were to have a production facility in Grand Forks to make cathode material, having stuff coming from Florida and California and whatnot, that's possible, but it definitely adds to the costs of the production of this material. And when you're trying to compete with those Asian markets, the cost is very vital. So having a good, robust mineral supply chain close to where that manufacturing process is happening is very key. Next slide. And one of the reasons it's really important, this is from that same DOE report I've been referencing, is that today no lithium iron phosphate cathode material is being produced in the United States, pretty much North America. There's a little bit being done in Canada, but nothing is being made here. So when talking about these critical minerals, for us, if the United States really wants to have control of its supply chain for energy storage, the cathode production is a major, major player in this. And in order to have successful cathode manufacturing, you need to have successful raw material mining going on in North America in order to make this work. And with those growth numbers that I showed on the earlier slides, it kind of all starts telling a story about why this is so important. And, from a national defense side, but also from an economic side. So as a company, this is something that we're very focused on. We're hoping to stand up our first cathode plant here in the next few years, with construction starting very soon. And yeah, so that's just a quick 10-minute on our company and what we're trying to do and why we think this is very important. So I was excited, Bruce, when you were talking about some of the coal deposits there in Western North Dakota. Some of the research we've done has been on lignite coal and how we can use some of the byproducts of that mining in some of this cathode material. So that's very exciting. And I really look forward to seeing what happens here in the future. And that's it for me. So I can take questions if anybody's interested.
I will apologize. I neglected to say at the very beginning, we are welcoming questions and we encourage you to use the chat function and to throw some questions in there. And while you're thinking about that, I'll step through just a few more slides. We go to wrap this up and then we'll focus on any questions that you may have. So Dan, if you'll go to the next one. So based exactly on what Ryan was just presenting and the DOE being fully aware of this, funded a program called the Carbon Ore, Rare Earth, and Critical Minerals Initiative, which we call the CORE-CM program for short. And you can see listed there the main focuses and drivers for that program, with big ones there being economic growth and economic and national security. And again, it's a way, certainly in other areas that are being profoundly affected with the reduction in coal-based electricity generation, that there may be other uses for that, and that coal is not just a fuel, it's an ore. And ores contain elements that can be used in other production schemes. Next slide. So with that, then, the DOE has funded 13 initiative teams across the United States that are, as you would guess, just very related to the basins and where coal is deposited. Williston Basin being number 6 there in the gold. And so we are focused on that region. And as you can see, these are not isolated areas, even though we are talking about basins. These basins do meet up with others. And so I think this sets up a lot of potential on regional scales that many of these initiatives, most likely as we step to the future, will be working together as we all develop our critical mineral resources that are contained locally. Next slide, please. And so with our project team in the Williston Basin Core CM program, you can see they're listed. It's a well-diverse team, and I am extremely thankful for all of them as we also integrate ourselves and communicate with many of the other Core CM teams located throughout the United States. But this team involves not only universities within the Basin region, but it's bringing in utilities and mining companies and geological survey organizations. It's very diverse. Next slide. So before we wrap up, of course, we always have to throw out the disclaimers. And so this is the disclaimer as related to the Department of Energy. And next slide, Dan, is the disclaimer for work being done through the North Dakota Industrial Commission and the lignite research that is conducted. Go ahead and jump to the next slide. We won't have you memorize those. I won't test you on what was in those last two slides. But at the end of the day here, I'm hoping that you come away from this webinar with 4 basic takeaways. The first is I hope you start to understand the vital role that critical minerals do take with our modern economy and how that could be an effect on our national security. I hope you've also come to understand and recognize more that critical minerals are imported commodities and our access to them can be very vulnerable within the supply chain just due to disruptions internationally. And certainly current world events, if any of you deal with supply chains of any kind, I'm sure you've seen how prices have risen dramatically this year with what's going on in the world. Third, I hope you walk away with a better appreciation of what the Williston Basin has to offer, not only with its lignite coal resources, but Bruce had even mentioned that there are waste streams available within the basin by which we may be able to take advantage of critical minerals that may be available with those streams and be able to utilize those. And then just finally, the last one, that the Williston Basin could become a regional economic hub. And there is a lot of potential here to grow this industry within the basin that extends beyond and may even integrate itself within what's being developed within other basins around it. Next slide. So with that, just a reminder that we have the upcoming webinars that I mentioned at the beginning today. You will be getting invites for those, so be looking for the emails on these as we get closer to the time. And one last thing I want to mention, next slide, is that next month, the Williston Basin Core CM program will be hosting a symposium in Bismarck, North Dakota. And on Monday, October 10th in the evening at the North Dakota Heritage Center, which is located right next to the Capitol, we will be having a small reception. And at that reception, the president of the University of North Dakota, Andrew Armacost, will be giving a keynote speech. President Armacost, I think, has a unique perspective with his background with the Air Force and with the Air Force Space Command. He has a good understanding of the importance of critical minerals and the role that they could play for national security and domestic security and material supply. And then during the day on October 11th, we will be at the National Energy Center, which is located on the grounds of Bismarck State College. We'll be conducting the seminar where we will be going through in more detail information that we have gathered and what we are finding about the availability of what we have in the Williston Basin and what we are projecting could potentially be those next steps as we move forward in developing the critical minerals within the region. And the keynote speaker on Tuesday will be Randy Chrisman, who is one of the North Dakota Public Service Commissioners. Randy's been working as a public service commissioner for some time now, and he has a great understanding of the economic importance of lignite coal within the region and how it plays economically, certainly within the state of North Dakota. So I would encourage you, if you have the opportunity and the availability, we would love to see you come out and attend. And with that, do we have any questions that have been posted so far with anything?
Keith Bome asked, and pardon if I said your name wrong, how does the Williston Basin compare in concentration of rare earth elements to other basins?
Bruce, I want to answer that question.
Sure. The Williston Basin is somewhat unique in some of the findings that we've had, where we're approaching 1,000 part per million rare earth element concentration, total rare earth element. Not very many places will you find that, and that's top 4 probably in the United States in coal resources. Now the Appalachians, they have a different environment for rare earths, and in particular, one of the things that they're looking at out there is acid mine drainage, where water will seep through old mines and pond up outside of the mine in some location, and water becomes acidic as it's flowing through those abandoned mines or old mines, and even active mines. And so the acids will extract the rare earths. While you have a toxic kind of sludge, it is high in concentration in these small localized areas. So that's a unique situation, but the Williston Basin is pretty unusual, high concentrations we find.
Thanks, Bruce. How far along in the investigation are the other basins compared to Williston?
So all of these initiative programs started about the same time, and by about the same time, I'm talking about the last quarter of 2021. And so in some respect, we're all at about the same level of development. Some basin initiatives may have advanced a little further with some of their economic projections. Other basins may have progressed in the characterization of the resources that they have. We're very similar in where we've gotten. And as a matter of fact, next month, the Department of Energy has called together a workshop, and all 13 initiative groups will be meeting in Pittsburgh to have discussions, hopefully to promote discussions across initiative groups as we learn kind of where everyone is and what's being discovered. And I'm hopeful that will also spur a little more collaboration, perhaps amongst groups where we see some positives and negatives where we can bolster each other up and improve the overall program.
Here's another question. In terms of processing the elements in minerals, is the thought that it will take place near the mines?
So Bruce, what is the current thinking on that now?
That's the original thought, is that because the western half of the state is where all these coal deposits are, so you'd set something up that would accept material from, you would think, from all of the different mines and the available sources and process at one spot. Certainly that could be 2 or 3 locations for initial processing and concentration, and then for the final separations and mineralization and production into alloys, that could be at a different location, but would certainly be near the mines, and some of the processing would take place probably within the mines themselves.
Okay, and John and Bruce, will that be addressed in one of the other webinars? More, do you think? Are we looking at that at this point?
Yes, we are. And in the next webinar, we'll talk a little bit more about the extraction technologies and where that development phase is and where we see it.
And again, in the webinar after that, discussing some of the business concepts, that is certainly being looked on that side as well. And I believe they will have some insights on that also.
Okay. We are coming up on the end of our hour, and I don't know if I'm seeing any more questions.
All right. Well, again, I thank all of you for attending today, and certainly afterwards when you get the information, and of course my email information is here, and it will be on the link you get to this information in the forthcoming email. Days from now, as you develop thoughts and have questions that may pop in, please feel free to email me, and we'll be sure to get back in contact with you and try to get the informations and the answers that you're looking for. So with that, thank you, everyone, and look forward to seeing you on the next webinar in November. And those of you that are going to be in Bismarck next month, I look forward to meeting and talking with you in person. And with that, I wish everyone a good day.